I was asked to come and explain everything that's happening in IT and AI and everything that might mean for enterprise software, and not talk too fast, and also take a very limited amount of time because you're on a tight schedule and you hit every time on your schedule with perfect regularity. So I'll probably manage a couple of those things, but you'll have to judge the rest. I think a good place to start in thinking about AI is to ask what we mean when we say AI. This is a quote from a pioneering researcher in 1970, Larry Tesler, who said AI is whatever machines can't do yet. Because once AI once it works, then people say, well, that's not AI, that's just software. Indeed, if we go back to the 1970s, you think about all those science fiction movies about computers taking over the world. Databases were AI. Databases had superhuman memory. And now it's just legacy software. 10 years ago, machine learning was amazing, and machine learning was AI. And today, I think, for most of us, machine learning is just software. NLP, image recognition, voice recognition, these kinds of things, and that's not AI anymore. You take a picture of your children with your phone, and it recognizes them. That's not AI, that's just software. 10 years ago, that was AI. And today, we have these things called large language models. And some people say, well, this is a path to AGI or superintelligence, and it certainly seems to be AI. And everybody wants to know what their AI strategy was. Just as a couple of years ago, everybody needed a 5G strategy, and we don't talk about that anymore. And so some people think, well, this is a fundamental change in the nature of civilization, and for other people, well, this is probably just more software. So if we go back to the beginning of 2023, the time that this had really started working and really started getting exciting, there was a whole cluster of questions about what this would mean, everything from intellectual property to chips to sort of how do we think about error rates. But there was really kind of one fundamental question, which is this going to keep scaling? Because we didn't actually have a theoretical model for how this worked. We just knew that if you made the models bigger, they got better. So the question is, well, if we keep making them bigger, will they keep getting better? And that kind of sets a range of outcomes. There's one outcome that says these things will just keep getting better more or less indefinitely, and will reach a point that you can have kind of one or two computers that can just kind of control everything. You can go to the computer and you can say, I need to do my taxes in Delhi, or I want to buy a house in Singapore, or I need to use Workday, and the computer will actually be able to do it for you. Workday might be a bit more difficult, actually. The other extreme is this ends up like SQL or spreadsheets. It becomes another API call. There are thousands of them or hundreds of thousands of them. And if you were to ask today how many databases are there on your phone, the answer would be, I don't know, 50, 100. It doesn't make any difference. And that may be where these things come out as well. So this is the sort of the foundational question, is how big does this become? Does it become something that isn't like software anymore? Because if we think about the sequencing of tech over the last 50 or 60 years, what's happened is that every 10 or 15 years, there's a platform shift. So we have mainframes from the mid-60s to the late 70s, and then PCs, and then the web, and then smartphones. And each of these are the center of the industry. They're where all the new innovation and investment and company creation happens. And you could put a few other things on here. You could put open source on this, or you could put cloud on this as well for the enterprise. And the whole thing doesn't go away. Like some big companies still run on mainframes. Big companies today will run on PCs. But the new thing is where all the innovation and the creation and the disruption happens. And so there's one view that says, well, that's what generative AI is. This is the next platform shift for the next 10 or 15 years, and then there'll be something else. There's another view that says, no, this kind of blows off the top of the chart. This is more like the new computing, or this is the new electricity. This is a much more fundamental change in what we can automate, in what people are going to be able to build. What have we learned since then? Well, you've already seen some model charts. These are my model charts. This is a score of model quality versus time. And what we've seen is that models seem to be commodities, and there are lots of them. To begin with, OpenAI was well ahead of everybody else. Today, OpenAI is probably still first amongst equals, but there doesn't seem to be any particular barrier to creating a state-of-the-art model. OpenAI's lead is basically gone. Other people build models too. And DeepSeek, which everyone got very excited about 6 months ago, really just kind of proved the point that anybody with $500 million can have their own state-of-the-art model. Now, $500 million isn't nothing, but the tech industry is quite big now. There's a lot of people that have got $500,000. And so there's something between half a dozen and a dozen people who are building a state-of-the-art model that can get onto this chart. Another way to think about this is to think about pricing. And so this is an axis of model cost, again, versus model quality. And what you see is that there's a very, very steep curve. So you can have the best possible model, or you can have a model that's sort of 90 to 95% as good as that for kind of 5% of the cost, or even 1% of the cost, and many of those models may be able to run on the edge or indeed run on a smartphone. So there's the old phrase in tech, better, faster, cheaper, pick two. That's kind of what goes on in this space. Do you want the best model or the best cheap model? So we've had 2 years of model wars, 2.5 years of model wars. What have we learned? Well, there doesn't seem to be an answer to the scaling question. It's carried on scaling for now in different ways, but we don't know if that will continue. We've got lots of progress, lots of exciting new possibilities with multimodal and agents and reasoning and chain of thought. We've got an ongoing pricing collapse. These things are the kind of the most expensive and fastest depreciating assets in history. But the models themselves seem to be commoditizing, and there doesn't really seem to be a moat. The only moat that there is capital. Have you got enough money and have you got enough chips? So NVIDIA is now selling something over $45 billion of GPUs every quarter, and that still seems to be going up. And about half of those are going to these 4 companies, going to the four cloud companies. Collectively, these guys spent about $120 billion building in cloud infrastructure, which basically means building cloud infrastructure last year. This year, they'll spend something over $300 billion based on their public statements. Of course, that was before Trump kind of destabilized the tech industry, but that was what they were planning at the beginning of this year. And it's kind of interesting to look at how that's shifting some of these companies' business models. I'm old enough to remember when Microsoft's business was putting a $1 CD in a $5 box and selling it to you for $300. It's kind of a nice high-margin business. Today, Microsoft is planning to spend about 30% of its revenue on CapEx, which is about double what a telco typically spends. So this has become very capital intensive. What is it that's driving all of that spending? Why are they spending all this money? Well, if you listen to the conference calls, there's 3 things that come out. First of them is we can't keep up with demand. This is something you hear from Microsoft and Google in particular, that the number of people hitting their APIs to run useful software is larger than their capacity. Secondly, they talk about the infrastructure being fungible. That is to say, they'll build this stuff and to build new models, and if they can't build new models or the new models stop getting better, well, they can use it to run the stuff that they already have, so it won't be wasted investment. And thirdly, asymmetric downside, which is another way to say, if this is the next platform shift, they don't want somebody else to be doing it better than them. They want to make sure that they have a strategic position in the future of the tech industry. Another way of looking at that is Sergey Brin a couple of months ago saying, this is the race to AGI. This is what we're going to be building. We're building kind of superhuman computing. Of course, people have said that before. This is Marvin Minsky, also in 1970. In 3 to 8 years, we'll have a machine with the general intelligence of an average human being. He was right. He's still right. In 3 to 8 years, we will have a machine with the general intelligence of an average human being. And he may always be right. We may be saying this in another 50 years. We just don't know. Meanwhile, there's some very kind of practical business questions, particularly if you're paying for those APIs, which is, what is this going to get charged at? If you look at Jensen Huang doing his kind of 2-hour keynotes in leather jackets, he talks about kind of that $300 billion going up to like $1 trillion or $1.5 trillion. Sam Altman at OpenAI talks about selling people software agents at thousands of dollars a month. On the other hand, if we think about how these technologies have always worked in the past, they always went to flat rate bundled pricing. You don't pay Google per email. You don't pay Meta per picture. What normally happens is that when infrastructure is a commodity, when it's open source, when it just becomes generic infrastructure, then it tends to get sold at marginal cost, and that tends to get wrapped into something else. Often the compute gets pushed out to the edge, and so it gets very, very cheap. One of the answers to this that people tend to come up with, incidentally, is something called the Jevons paradox, which is basically the idea that if something gets cheap, people use more of it, which is true, but people forget that doesn't necessarily mean you make more money from it. So if you were to say to somebody in the airline industry or the telco business, if the thing gets really, really cheap, then your revenue will go up, they will give you kind of a sad smile, because that isn't how it works. We have now something like 150,000 times more mobile data being used than in 2010. I think you can probably guess that mobile revenue hasn't gone up 150,000 times. So this kind of takes us back to the scaling question, though, because this is, I think, what matters to everybody in this room. How much better does this stuff get? It kind of determines what the software looks like. Because if this stuff just gets sort of indefinitely better, then you could go to the LLM and ask it to use Oracle for you. You could go to the LLM and ask it to use all of your other tools. If, on the other hand, what happens is, the other outcome, though, is this sort of becomes an API call like everything else. It becomes a tool, a building block, a primitive that every other kind of software uses. And I think the real answer to this is no one really knows yet. This is a diagram of the internet produced in 1995, except it's not actually called the internet, it's called cyberspace, which is a very mid-90s word. It also talks about the matrix, which is even more mid-1990s. And the reason that the point of this diagram is it was clear that everyone was going to have some kind of computing thing connected to some kind of a network. But it wasn't clear that that would be the internet, because there were lots of other networks. It wasn't clear the internet would all be about the web, because there were lots of other things happening on the internet. It also wasn't clear that the value capture in the web was going to be in search advertising and social media. Those didn't exist until 5 or 10 years later. And we're kind of at a similar point today. It's clear this is a very big deal, and there's a lot of value there. It's not actually clear what the market structure is going to be, where the key gatekeepers are, where the key value capture is going to be, and of course, what it is that you're actually supposed to do with this, because that wasn't clear in 1995 at all either. That takes me on to the second part of the presentation, which is, okay, that's all great, Benedict, but why is this useful? Why are we spending hundreds of billions of dollars on it? And this is a question that people kind of came back and asked this time last year, last spring, last summer, when some people noticed just how much CapEx was going into this and said, well, okay, but where's the value? Are you actually going to get any revenue from this? Why are you spending all of this money? Isn't this getting a little bit, are we getting a little bit ahead of ourselves? And I think a good place to answer that is to try and sort of sit down and think, like, how would we, like, at a conceptual level, think about what this software is, what this technology is, what it can do? I think it's kind of interesting to go back and look at machine learning 10 years ago, because machine learning started at image recognition. And you could have gone to people like this, or you could have gone to a big insurance company and shown them image recognition, and they would say, well, that's great, but we don't have any pictures of cats. We're an insurance company. And it took a while to work out that machine learning was pattern recognition. And once you knew it was pattern recognition, then you could realize there were lots of other things you could do with it. We're sort of at that point with generative AI, like, how do we think conceptually about what this is? And I think this is kind of one useful model to think about, that traditional software, like databases, do things that are easy to explain to a computer. It's easy to tell a computer how to calculate a mortgage. It's hard to do it in your head a million times, but it's easy to tell a computer how to do that. What machine learning solved 10 years ago was problems that were hard to explain to a computer. Like, why is that credit card transaction weird? Does this customer sound angry? Is that a picture of a cat or a dog? Those are problems that are easy for people but hard for computers, and machine learning solved those problems. What do we do with an LLM? Well, maybe one way to think about this is that they do things that are easy to explain to a person. If you could ask somebody to do that task in 2 or 3 lines, or maybe a paragraph, then you can probably get an LLM to do it. If the way to get a person to do this would be to show them 2 or 3 weeks of context and to sit down with them for half an hour, then you're probably going to struggle to explain that to an LLM and get an LLM to automate that for you. In other words, there's a sort of basic puzzle here. What do we do with a technology that can automate stuff we couldn't automate before when we don't quite know what that is? And it might get it wrong. One answer is to say, well, do you have a use case? And I think this is a great example of that reasoning. This is VisiCalc, which was the first successful software spreadsheet from the late 1970s. The Apple II and here to run this, along with the monitor and the disk drives and the printer, cost about $15,000 adjusted for inflation. We kind of forget how expensive computers used to be. But before this existed, spreadsheets were paper. You can actually buy paper spreadsheet on Amazon now. And so you would fill in all the cells one by hand with a pencil. And if you made a mistake, you had to go and redo 200 or 300 cells. And so Dan Bricklin creates this, and he shows it to accountants. And he says, look, you can change the interest rate here, and all the other numbers change. And we look at that and we think, yes. But if you're an accountant in 1978, that was like a week of your work that had just done in 10 seconds. And so for those people, they had to have it. But if you were a lawyer, you would look at this and think, well, that's great, and my accountant should see this, but I don't have that use case. I don't do that every day. And I think that's what we're seeing with first waves of adoption of generative AI, which is there are some people who really, really, really have that use case. So software development is a huge thing now with people talking about 10, 20, 30% efficiency gains already. Marketing is seeing something similar. Customer support, which we already heard about just now. is already becoming sort of something you have to be a little bit careful with, but having a lot of adoption right now. And then early adopters across every industry, the people who are already always interested in picking up a new tool and playing with it. In particular, it's worth thinking about software development, and it's interesting to compare this with AWS. So here is a quote from Y Combinator saying that for about, this is a Silicon Valley incubator, for about a quarter of their startups, 95% of the code is written with AI. Now, that sounds great. You also have to point out that if you write an iPhone app, 95% of your code is written by Apple. If you write a Windows app, 95% of the code is written by Microsoft. So there's always a layer of abstraction. But it's interesting to compare this with AWS, because what AWS did 10 or 15 years ago was an order of magnitude change in what it costs to build software and get it to market. So famously, Instagram, I think, had 7 employees when Meta bought them, and they had 35 million users. They didn't need to buy boxes from Sun. They didn't need to buy boxes from EMC and software from Oracle. They could just sit on top of AWS. And so it may be that there's another of these kind of step changes in what it costs to create software and get it to market, because you can use AI instead of having to write it all of yourself. However, for everybody else, like people who don't write software, aren't in marketing, aren't in customer support, aren't early adopters, there's a lot of kind of puzzlement. And so this is one survey that was done in the US at the end of last year. I could show you half a dozen or a dozen other surveys that show kind of the same thing, which is that sort of 10% of people are using this every day now. Another 10 or 15% are using it maybe once a week. And then another kind of 50% of people have looked at it and said, well, that's great, but I don't quite know what to do with this. I don't know how to use it. And that gets me to this great quote from Steve Jobs, where he said, it's not actually the customer's job to know what they want. It's not the customer's job to know what to do with software. When people in this room were starting their careers, like, you didn't go to Oracle and buy SQL. You don't go to Salesforce and buy database. You buy products and solutions that solve your problems. And that's the job of the software industry. One part of that is big companies go and work with companies like Accenture to automate their processes. Accenture billed $1.4 billion of new generative AI bookings last quarter. And this is what we always used to call digital transformation. In fact, if you say digital transformation 3 times, then a partner from Accenture will appear in a puff of smoke in a corner of the room and offer you a contract. And so that's one part of how this gets deployed. Another is that every big company is doing pilots. And so here we see the gap between the pilot and the deployment. And it's kind of interesting, like basically everybody has a pilot. Conversion from pilot into deployment takes a little bit longer. And again, it's kind of concentrated in software, marketing, customer service. If you tail off to things like HR and legal, it takes a bit longer. And again, this is another view on the same data. This is survey data from Morgan Stanley. Surveying big company CIOs, something like 20 to 25% of people have deployed at least one thing now. Another 40% don't plan to deploy anything before 2026. And you could say, oh, well, yes, but that will change. They'll move more quickly. But it actually always takes time to deploy new things in big companies. I probably don't need to tell that to people in this room. The enterprise sales cycle is not 3 months. It's more like 18 months to 2 years. And there's kind of 2 parts to this chart. One of them is, for everyone in this room, kind of cloud is old and boring and finished and done, and like that's a story from the last decade. But it's still only sort of 20, 30% of enterprise workflows. The other part of this chart is that CIO is always desperately trying to believe that they'll manage to get budget to re-platform their company. And then the CIO, CEO say, nah, not this year. And so they always hope that they'll be able to convert it in 3 years' time and never manage to do it. Now, there's some sort of specific hesitation with big companies around using generative AI. People worry that their own data will leak. People worry there might be other people's data in it. People worry about the error rates. There are always reasons why the big company won't use the new thing. This is why people didn't use the cloud. It's why people didn't want to convert to SaaS. People didn't want to convert to the web or to PCs or to mobile. But there's also, of course, these kind of use case questions. But as you go through that process, platform shifts always mean more tools. When we went from mainframes to PCs to SaaS, the typical big company today uses 400 to 500 SaaS applications. Generally, the IT department only knows about half of those. The other half are shadow IT, bottom-up deployment from within the company. And so there's a kind of a basic kind of process here that says, well, this is going to give us another wave of hundreds and thousands of new companies that will automate things inside the enterprise, just as each of these previous waves of technologies have done. Some of those, of course, will come from companies in this room. Some of them will come from big incumbents. Some of them will come from startups. This is just an example of this. The function of a startup is to invent use cases, to find problems, to unbundle things out of Oracle or Microsoft or Google or Salesforce and turn them into a company, and then go out and try and deploy those And that's what we see coming out of Silicon Valley today. This is Y Combinator I mentioned a moment ago, the big Silicon Valley incubator. Basically, all the startups in Silicon Valley are now AI companies. And so that gets me to this question, well, what's our AI strategy? Well, is that a CIO question or a CEO question? Is it kind of an Accenture question, or is it kind of a Bain, BCG, McKinsey question? And the answer is all of those, depending on what it is you're trying to do. Because whenever we get these kind of new waves of fundamental technology, you kind of go through this process of adoption. To begin with, you try and absorb it. The incumbents always try and make it a feature. So you can see Google and Microsoft and Meta and Apple looking at ways that they can just add it to what they're already doing. Big companies use it to optimize processes that they already know about. You've got all these things where you can immediately see, I could use generative AI for that. Then, a little bit later on, you start innovating. You start inventing new revenue lines. You start thinking of things that you couldn't have done before. New products that you can build, new capabilities you can add, new features you can create. And you look at ways that startups start looking at ways that they can unbundle the incumbent. How can you unbundle Oracle? How can you unbundle Microsoft or Salesforce or Google or whoever? A little bit after that, then you start having disruption. You start having people who are actually fundamentally redefining a market. They're coming in and changing the questions. The cliche is always that Uber doesn't sell software to taxi companies and Airbnb doesn't sell software to hotels. They change what taxis and hotels mean. And we've got some sort of early glimmers of that as we look at LLMs. This is the one that everyone likes to talk about, is how does this change search? So if you want a chocolate chip cookie recipe, you go to Google, you hit search, you get 170 million results. They're all basically the same. And there's a huge amount of SEO and SEM and optimization and spam and farming and all sorts of other crap going on around this. Or you can just go to ChatGPT and say, give me a chocolate chip cookie recipe. And that's not actually a difficult problem, and it can be abstracted in a completely different way. But you can also push this one step further and think, well, this is still basically search. And of course, basically search is a big question. That's $500 million a year of ad revenue. But you can also think, well, what kind of problem am I trying to solve here? So imagine you've got home late from work and you're trying to work out what to cook. And you look in your fridge and say, OK, this is what I've got. I type it into Google and look for some recipes. Or I can just take a photo of my fridge and give it to ChatGPT and say, what should I cook? And that's not really search anymore. That's something else. That's kind of getting at an underlying question and pushing it in a different way, redefining it, trying to take that in different directions. And so we get these kind of questions around, like, well, how is the web going to work? Is this the end of the web? Does this mean the end of links? What is the content that only existed because of search? Why are there 100,000 chocolate chip cookie recipes on the internet? It's not because 100,000 people have unique visions for what a cookie should look like. It's because of Google. So how does all of this change? How does it move around? How does $1 trillion of annual ad revenue move around? Because global ad revenue is about $1 trillion. Roughly half of that goes to Google and Meta and Amazon. Where does that go? How does customer discovery work? How does the internet change? How do we think about problems of kind of infinite content, infinite discovery, infinite retail, infinite media, if you could just go to an LLM and ask what you should buy? Kind of step back from that. All of the kind of questions, I think, that come out of generative AI, in the end, aren't really AI questions. So you can ask what translation or dubbing or indeed special effects will mean for the movie business, but that's a movie industry question. And there's a huge amount of excitement now about robotics and how AI changes robotics, particularly humanoid robotics, biped robotics. What does that do to the logistics industry? I have no idea. You'll need to ask someone in the logistics industry. What does it do to professional services, consulting, law, banking, people who do inspirational presentations in hotel ballrooms in Orlando? Well, we'll find out, but that doesn't seem like an AI question. So all of which is to say, well, here we are in the next platform shift. And we should just kind of take a step back briefly and remember all of the stuff we were excited about before ChatGPT launched is still there and still happening and driving everything else. So e-commerce is now sort of 20 to 30% of retail revenue, depending on where you are. Amazon has a $60 billion advertising business. China is about to overturn the global car industry. All of the stuff that was cool and exciting and scary before ChatGPT launched is still there and kind of gets accelerated by this. And so the tech industry is always very excited by stuff that's going to happen in like 5 years' time. So that would be VR, AR, crypto, robotics, nuclear, computational biology, self-driving cars. That's all kind of cool and exciting and fun to talk about. Meanwhile, every company today is being founded on today's big thing, which is generative AI. If you've got a startup in Silicon Valley and you're not working on generative AI, everyone will kind of point at you and laugh, like what's wrong with you? Meanwhile, all the rest of the economy is deploying ideas from 5, 10, 15 years ago. Ideas like SaaS, cloud, automation, like wild, bizarre, crazy ideas like maybe people will buy clothes on the internet. Remember that? That was like a 1995 idea, whatever. And yet it takes 20 years. Or it takes 10 years, or it takes 5 years for these things to come to market. And so every company today is being overturned by ideas from sort of 5, 10, 15 years ago, but meanwhile having to think about, well, how does that get changed by generative AI? How does that get changed by robotics? How does it get changed by search and discovery? And then meanwhile, there'll be something else in another 5 or 10 years that we have to get excited about. But meanwhile, we've got plenty of stuff to build. Thank you.